algebra. We're doing some index laws. Let's read through the stuff at the top of the page. Pronumerals are the letters in the equation. Our equation has two pronumerals. They are called x and y. They are often used in the place of a number. You guys know that. Adding and subtracting. Anytime you are adding and subtracting with algebra, you can only add and subtract like terms, which means they have the same pronumerals. Don't worry about the order of the letters. An xy is the same as a yx, isn't it? They just need to make sure that they are all the same. The powers must also be the same for them to be like terms. Multiplying and dividing algebraic terms is different. You don't have to have like terms. When you are multiplying or dividing, if you're multiplying, you multiply any numbers together and the letters collect up. When you're dividing, you divide the numbers and the letters cancel out. Okay? So there's some hints there in the box as a summary to do that. The index laws, again, you've seen these many times, so we'll go through them quickly. If we are multiplying indices, which means we have the same bases, all we have to do is add the powers. That's index law number 1. Base stays the same, powers get added. If you are dividing, either with a divide sign or a fraction, means the same thing. When you're dividing in indices, the base stays the same and the powers get subtracted. So it's m, take away m, subtracting the powers when dividing. Third law, if we have power in the bracket and outside of the bracket, you must multiply those together. So that will become m times n. Multiplying those powers together when there's brackets. If there is more than one thing inside the bracket, each of those must be to that power of m. So often people just put it on the last one. You must remember to also put it on the a. So a to the power of m and b to the power of m. And 5 is also just an extension on that again. Here we have a fraction inside our brackets with the power of m outside. And again, that power of m has to go to the top. So a to the power of m, and it must go to the bottom. Okay? Great. Looking like you guys remember those. So straight into the questions. Here they are. Simplify by collecting the like terms. So I have 2mn and an nm, even though the letters are switched, they're still like terms. Remember to always take the symbol in front, so I'm taking that plus sign. So 2mn plus another 1 will make 3mn. Or you could do nm, but we usually go for alphabetical order. But either one is correct. Looking for more like terms, I have also got a minus 3a and a plus 5a. Again, taking those plus and minus signs that are in front. So minus 3 plus 5 is a positive 2a. And last of all, I have that 4 sitting on the end. It doesn't have any like terms, so it just sits on the end, plus 4. All right, part B, slightly more complicated version, same thing, looking for like terms. An a squared b, here's another a squared b. The one down the end, don't be tricked, the squared is on the b, so it's not the same. So it's only the two that I've highlighted. 3 take away 1 is going to be 2a squared b's. I have some more like terms there. I have a 2ab plus another ab. So 2 plus another 1 is going to make 3ab. And that minus 4ab squared has no friends. He cannot collect with anyone, so it just sits there on the end. Minus 4ab squared. All right, over the page. Now we are into multiplying. So multiplying means we multiply the numbers out the front. So 3 times minus 4, that's minus 12. And any letters will collect up after it. If I have got two n's, like I do there, that's going to become an n squared. Okay, so I have one m, I have two n's, that's n squared, and I have one p. All right, that's it. Put them in alphabetical order, just because that's the norm. Part B, dividing. We divide the numbers out the front, so 20 divided by 5 is 4, and we look for letters that we can cancel. So Z and Z will cancel off completely. The Y's won't cancel completely, but I can cancel the second one with one of the ones out the front, because there's two of them there. There'll still be one remaining. And I can cancel one X with one of those three, and there'd be two left over. Be careful with your cancelling out. Be neat with it so that you can read what you've written there and you're not going to make a silly mistake, okay? So it's 4. I have X squared, and I have 1Y. Question 3 is focusing more on our index laws. So I'm multiplying with the same bases. So what do I do to the powers? Add them. So A is the base. 3 plus 5 is 8. Base stays the same. Add the powers. Part B is just a combination of more of those. So we have the numbers out the front that we multiply first. 3 times 2 is 6. Then we do each letter separately. So let's start with the M's. I have 2 plus another 5 is going to make M to the power of 7. Now I'll look at the N's. I have 5 plus another 4, which makes 9. Yeah, am I going too fast? No, we're doing well? It's all revision. Question 4. Simplify the following by using the appropriate index law again. So we're dividing. Dividing means if the bases are the same, we subtract the powers. So for the first one, K is my base. 12 take away 4 is 8. Part B, 5x cubed y to the power of 9 divided by 15x y to the power of 5. We don't really need those brackets there. It was just to make sure you divide by all of it. Okay? Now, there is a small problem there in that you can't really divide 5 by 15. It needs to be a fraction. So unless things divide out nicely, I recommend that you always rewrite these kinds of questions as a fraction first. So that one with the 15 on the bottom. Okay, that way you won't be tempted to put your x's or y's or go to a decimal, any of those kind of common mistakes in there. So then you want to simplify the numbers. So the 5 over 15 simplifies to 1/3. Everyone's okay with that? Then our letters. I have 1x on the bottom, which I can cancel with 1 on the top, which will give me 2. I still have 2 left on the top. I can cancel all 5 of the y's on the bottom, and I subtract 5 from that 9, which will give me 4 left on the top. Now, because I have a 1 on the top of that fraction, when I write my x squared y to the power of 4 on there, that now means that I don't actually need the 1 in front of it. Okay, it's kind of an extra. If you have it there, it's not wrong, but we don't normally write 1s as a coefficient of a letter. Okay, we leave it out. So that would be the best solution. Question 5 is using the index law of a power of 0. We didn't really discuss that one earlier. Anything to the power of 0 is equal to? 1. Excellent. Anyone who is in doubt of knowing what becomes 1, what I want you to do is always circle whatever is to the power of 0, because that is the part that becomes 1. The 3 is not a part of that. Okay? So a to the power of 0 becomes a 1, but then I still have 3 times by that 1, and my final answer is 3. So in part B, again, circle the part that is to the power of 0. M is to the power of 0 here, so that's going to become a 1. But in the second part here, all of that is in brackets. Shh, girls. All of that is in brackets to the power of 0, so that whole thing will become a 1. Okay, so just be careful. 5 times 1 will be 5 for the first term, plus 1 for the second term, means that the answer for that is 6. And part 6, now we're on to our brackets with our index laws. Remember, that means that you multiply any powers together. So for part A, m is my base, multiplying the powers, 3 times 5 is 15. If there is a number out the front, that must be to the power of whatever is out here. Do not times those together. Big, big, very common mistake is when people just go, 2 times 3 is 6. No, it is 3 to the power of 2, which is 9. Okay? So that has to be to the power of, not multiplied. The multiplying is the 5 and the 2. 5 times 2 is 10, so 9 to the power of 10. And question C, we just have lots of parts in there. Everything inside has to be cubed. So 2 to the power of 3, not times, to the power of, is 8. For A being the base, I times those powers together. 3 times 3 is 9. On the bottom, I have another big number here. So it's 3 to the power of 3, which is 27. B is the base. 2 times 3 is 6, will be the power for that one. And the C, it is currently a power of 1, so it would be 1 times 3, which is 3 for that. Look for any cancelling. Always look to simplify as much as you possibly can. But that's it. All right? Easy, right? 1 exercise down, 2 more to go. We're just going to plow through, do all 3 of them, and hopefully that will give you some time to get started on them after that. So on to the next one, expanding brackets. Expanding means we want to get rid of the brackets. So you've got a reminder up here. This is how we do our distributive law. We do A times X to get the AX, and then we do A times Y to get the AY. It doesn't matter if your A is at the end, although most people would probably prefer to rewrite that and just move the A to the front and do it normally. But you can actually still do A times X and Y, let me start that again. X times A and Y times A. It still works distributive law even if that A is at the end rather than the front. All right, examples. Maybe I should go faster. This is too easy for you guys, right? Yes. Okay, go fast. All right, so expanding out. 2A times 3A. 2 times 3 is 6. And the A's will collect. A times A is A squared. We have a minus sign in between, and then we want to multiply 2A times 5. 2 times 5 is 10. Done. That's a little bit too simple. Let's get a bit harder. Next one has 2 sets of brackets. We just expand each one separately. So 3m times 2. 3 times 2 is 6, and the m sits afterwards. Then we have a minus sign. And we want to do 3m times 5n. So 3 times 5 is 15. And we have 2 letters there, an m and an n that have to collect up afterwards. And for our second bracket, that minus sign also has to be expanded through as well. It is minus 2n times a1, which is minus 2n. But it's usually this second one that tricks people. Minus 2n times a positive 4m will make a negative, because a negative times a positive is a negative. 2 times 4 is 8mn. Okay, so that next one should be a minus sign. Once everything's expanded, look for like terms. I have got 15mn or minus 15mn and a minus 8mn. So minus 15 minus another 8 is minus 23. The other ones are not like terms. So I have a positive 6m and I have a negative 2n. It doesn't matter if you had done it in a different order, as long as you have the signs in front correct. So if I had written 6m first, 6m minus 23, sorry, that should have been 23. I forgot my 3. I said 23. If I had gone 6m minus 23mn minus 2n, it's still the same thing, as long as you have the correct terms.
For A.
Yes.
Is it?
Oh, there should have been an A there as well. Is that what you're about to say?
Yeah.
Thank you. I missed an A for my second expanding. That's how easy it is to make a silly mistake. Okay, then we get on to question 2, which is our basic FOIL expansion. So if you need a little reminder, there's your FOIL. First, outside, inside, last is what that stands for. So first means the first thing in each bracket. A times 2a is 2a squared. Then a times by a3, because that's the outside, the two outside things in the brackets. A times 3 is 3a. I is for inside, the two inside ones here. Minus 2 times a positive 2a is minus 4a. And L is for last, which is the last thing in each bracket. Minus 2 times 3 is minus 6. And then collecting the two middle ones because they are like terms. So 2a squared, 3 minus 4 is minus 1, or just minus a, minus 6. Now that's a normal FOIL because we have two things in each bracket. Part B, you notice that we have 3 things in that second bracket. We still use the same basic principle. We want to multiply everything in that first bracket with everything in that second bracket. So the 3, I'm going to multiply it by the 2, then I'm going to multiply it by the 3x, and then I'm going to multiply it by the x squared. I multiply it by each one. Okay, so let's do that. 3 times 2 is 6. 3 times 3 is 9x for the second one. And 3 times x squared is 3x squared. Okay, so I've multiplied the 3 by everything in that bracket. Now I need to multiply the x by everything in that second bracket. So the x times 2 is 2x. X times 3x is 3x squared. And x times x squared is x cubed. Now, usually, and it's not a must, but usually if you have different powers of x, you start with the highest power of x and work your way down. So my highest power of x, when I look at that, is an x cubed. There is only one of them, so that x cubed is going to sit there at the beginning. Then I'm looking for x squareds. Yeah, it doesn't matter, but it's just one habit, a habitual thing to do, just to make sure you don't miss anything along the way. Extension people, it probably does matter more because when you do polynomials, they do need to be in order for things that we need to do. So it's probably a very good habit to make sure you guys definitely do it, okay? X squareds. 3x squared plus another 3x squared is a 6x squared. I have 9x plus 2x, that's 11x. And the constant term is the 6. It's only one of them, so it's on the end. All right. Question 2. Expand using shortcuts if you can. So if you're ever stuck, you always resort back to FOIL, okay? For anything with 2 terms in the brackets, you can use FOIL, okay? But if you can use a shortcut, it's going to save you time. And the more time you have in a test, the more checking you can do, the more time you have for those harder questions. So it's just better. If you can do it, then please save yourself the time. So let's try to do these ones with our shortcuts. So this one, when you have a bracket squared, the shortcut to expand it is to times the first thing by itself. X times x is x squared. So it's that one times by itself. Then you do 2 lots of these 2 things multiplied together. So I always multiply these together first. That's minus 3x. And then I double it. So that's minus 6x. And then the last step is to multiply whatever's in the second position by itself. Minus 3 times minus 3 becomes a plus 9. So first one times by itself, times both things together and double, last one times by itself. That's the shortcut. Try it again. Same process. Do you want to have a second? See if you can do this one. Exactly the same thing. First one times by itself, times the two things together and double, and then the second one times by itself. Okay, so did you get the same thing as me? 2a times by itself, or 2a squared becomes 4a squared. Multiplying these together, you get negative 10ab, but I have to double that, so I get negative 20ab. And then this one times by itself becomes 25 and b squared. Yeah? Good? All right, part C and D. Can anyone tell me the name of those types of questions? Yes, difference of two squares. Excellent. That's what you're going to say, wasn't it, Ben? Okay, now these ones, if you can look at it and identify that that's a difference of two squares, what's going to happen? What is the thing that happens? The property that makes it a shortcut. Yeah?
It's always going to be the first one squared and the second one squared. Negative ahead of it and the middle.
That's right. Perfect. So if you think of your normal FOIL expansion, the O and the I, the middle two terms, will always cancel out. Okay, so your shortcut is just to go x times x, which is x squared, and minus 5 times 5, which is minus 25. So it's just the first one's times together and the last one's times together because the middle two cancel out. If you forget and do the full FOIL expansion, you're going to see it pretty quick that they should cancel out, but you just lost yourself a little bit of time. Okay, so the next one, the same. They're exactly the same brackets, but one's a plus and one's a minus. So we do our shortcut. 2x times 2x is 4x squared. Then it's 3y times minus 3y, which is minus 9y squared. Being able to do this stuff quickly will save you a lot of time. All right, and one last exercise for today. Factorizing. Okay, we now want to put everything back into brackets. We're just making sure that you have all those skills you need so that we can get into, we want to use them in some other topics. Okay, so by factorizing, here are the 4 basic types of factorizing. First of all, highest common factor. That's just where you take, they both have a factor of 5 and you factorize out that highest common factor. They're the easy ones you've been doing since year 7. Then you have the difference of two squares, which is the reverse of what we were just doing. Quadratics is when you have the 3 terms, like an x squared, an x, and a constant. You see your 3-term quadratic. And the grouping in pairs, usually you can identify that because you'll have 4 terms. Okay, you'll be able to see that one. All right, so let's have a go. Often the part of the problem is just identifying which method to use. Practice, practice, practice will get you better at it. Part A. So I only have 2 terms. There's no minus sign there. So the only thing that I can do in that question is to take out the highest common factor that I can find. So there's no number factor. The x's is where the factor is. X to the power of 4 is the highest power of 4 that I can take out of both of them. Then what I do is I put the leftovers inside brackets. So for the first term, I haven't used this 5 yet, so it needs to come inside. For the x's, I've got 4 of them out the front, but there's meant to be 5. That means there's meant to be 1 more that needs to be inside the bracket. For the second term, there is a plus sign. I'll put that down first. Plus sign. Second term, I haven't used this 4, so the 4 goes inside the bracket, but I have used all of those x to the 4s out here, so there's no more x's to write down. Close the bracket and that one's done. Easy peasy. Part B. There's a few more factors in this one. First of all, looking at the numbers, 12 and 15 can both be divided by 3, so I have a number factor, 3. Looking at the letters, both of those terms have n's in them. They both have an n squared. Okay, so that's going to be my letter factor. Now divide to find out what's going to be left inside the brackets. 12 divided by 3 is going to be 4. I haven't used any of those m's, so I need m cubed there, but I've taken both of the n's out. Now for the second term, I have a minus sign. 15 divided by 3 is 5. And I've taken the n squared out the front, so that's been used. All right, good. Next type, question 2. So that was type 1, taking out a common factor. Question 2 is going to be our difference of two squares. So you can see, because you have something squared here, minus, and usually, for the nice questions, that's a perfect square number. Not always, though, okay? But usually it's a perfect square number. All right, so as soon as you can identify that's a difference of two squares, I know it's going to go into two brackets like this. They always go into the double bracket. I square root the first term. Square root of that is just going to be an a. That's going to go at the front of both brackets. Then I'm going to square root this number here at the end. Square root of 64 is 8. It's going to go at the end of each bracket. Now, one bracket needs to have a plus sign in between and one bracket needs to have a minus sign. Doesn't matter which one you put first. One's a plus, one's a minus. All right, let's do it again. There is an extra catch with part B. It is a difference two squares question, but at the moment it's not very nice because I can't square root that and I can't square root that. So before I do it, there's actually a common factor that I can take out of that first. I can take out a factor of 5. So let's do that. If I take a 5 out the front, I will have 16a squared take away b squared. Okay? Now this becomes a much, much, much nicer difference of two squares. So the 5 is going to keep sitting there at the front, and I'm going to factorize it further into my double bracket. So to do that, first of all, square root the 16a squared, which will be 4a and 4a. Then I square root the b squared, which is going to be a b and a b. One will be a plus and one will be a minus. That's it. You can probably imagine what question 3 is going to be. We're doing our things in order. 3 terms means a quadratic. Okay, we have an x squared, x, and a constant number. So remember there's two different types of quadratics. There's the monic quadratic, monic meaning that the number in front of the x squared is a 1. Or basically there's nothing there, it's just a normal x squared. Then there is a harder one, these ones down here, these are still quadratics. These are the non-monic that have numbers in front of the x squareds. Okay, easy ones first. All we need to do is to look for two numbers that multiply to give the number on the end, 24, and add to give negative 11. I can see a lot of you already started working them out. What did you get, Tori?
I wasn't doing that.
Oh, you weren't doing that question.
X minus 8 and then x times.
Yes. So the x's will always go out the front. So you know it's an x squared, it's a quadratic, so you put x at the front of both brackets. So two numbers that times to give 24 is 8 and 3. But because I need a negative 11, it would need to be a negative 8 and a negative 3 to get two negatives to make a positive, the positive 24, but they also will make a negative number here. Is anyone still having trouble doing that? Because there is longer ways to write that out, like if you need to test answers. So you can come over here and you can go, all right, 24, what are the things that times give 24? It could be 1 and 24, it could be 2 and 12, it could be 3 and 8, it could be 4 and 6. And then once you've got your list, you go, all right, this is positive, which means either both of my numbers are positive or both of my numbers are negative. Okay? Now when I look at this, because that's negative, I know that both of my numbers have to be negative. That's the only way that's going to work. So I come through here and I go, oh, all these numbers are going to be negative. And which one of those sets makes a negative 11 when I add them? A minus 3 minus 8 more makes a minus 11. Maybe you didn't need to hear that again, but it couldn't hurt. If you need help, write it out. Okay, part B. We are looking for two numbers that times to give a negative 26 and add to give 11. Our A will be at the front of both brackets. Who can tell me what times to give negative 26 and adds to give 11? Yes, Jess.
-2 and 13.
-2 and 13. Very good. The more you do of these, the faster you'll get at it, and the less you'll have to write down as working out. You're right, India?
Yeah.
Yes? All right, good.
Just walked past and had some sick shades on.
Oh, did he? Okay. All right, question 4. For some reason, I'm sure you guys have been practicing all holidays, but anyway, last year, some people had some problems with these ones. Okay, let's make sure we get them right. To factorize these non-monic trinomials, what we do is we split the middle term to make a 4-term expression. Okay? To do that, the first thing you do is you multiply 2 by 12. The number at the front multiplies the number on the end. Can we have a little bit less chatter, please? Times is to give 24 and adds to give 11. So don't forget that extra step. It's not times to give 12, add to give 11. You've got to times that with the 2. So, Mr. Patrick, what times is to give 24 and adds to give 11? Very good. So what you do is you split. The 2x squared stays the same. The 8 and the 3 that Ben just told me means that I need an 8x and a 3x. The two numbers that you work out are the numbers that go here when you split that middle term. Now it's a 4-term expression, and you're going to factorize in pairs. So the first 2 terms, we can factorize a 2 and an x out of them. I'm just taking these 2 here. If I take a 2x out of that, I'll have an x left over. 2x out of the 8, 8 divided by 2 is 4, so it'll be x plus 4. Then take the 3rd and the 4th term. There is a common factor of 3 in there, so plus 3, leftovers inside the brackets. From the 3rd term, there'll be an x left, and 12 divided by 3 is 4. Now, assuming you've done it correctly, these brackets here should always be the same. If they're not, you factorize, either you didn't have the right numbers to start with, or you're taking out a common factor didn't work somehow. That means that this bracket is now a common factor. The x plus 4 is a factor, and you can put the numbers out the front, the 2x and the 3, into a second set of brackets, so 2x plus 3. Again, it doesn't matter if you put the 2x plus 3 first and then the x plus 4. It doesn't matter the order. But I like to think of bringing my common factor out first and then putting my leftovers into the other bracket. All right, let's try it again. Let's try it for part B. We need to first of all multiply the 6 with the negative 10. So we're looking for 2 numbers that times to give negative 60 and add to give that middle number, which is negative 11. Who wants to have a go? Times to give negative 60 and adds to give minus 11. Minus, yeah, good. So negative 15, Lachlan? Negative 15 plus 4. So leave the 6m squared. We needed a negative 15m, and we needed a plus 4m, and the minus 10. So the only change on that first line, the first term stays the same, the last term stays the same. I'm just splitting that middle term into 2. Now I factorize in pairs. So the first 2, I can bring out a 3 and an m. That will give me 2m minus 5. The second 2 terms, I can take out a factor of 2, which also gives me m minus 5. So luckily my brackets are the same. Oh, wait a second, I put my 2 there. Luckily my brackets are the same, and I can bring that out as a common factor. So 2m minus 5 and 3m plus 2 goes into the second bracket. All right, we're nearly there. Question 5. Factorize. So this is the last type, which is we've kind of already done this because these are the 4 terms. This is factorizing in pairs, just without the extra quadratic part to it. So it's all right. We have a double when we finish this. All right, so usually you try to do the first two together and the last two together. They're usually the ones that work. Sometimes they will try to mess with you though, but that should always be the ones that you check first. So if I try to do the 9xy and the minus 9x, those two terms I can factorize out of 3 and an x. 12 divided by 3 is 4. The x is out the front, so I just need the y inside the brackets. For the 9x here, 9 divided by 3 is 3, so I'm going to have minus 3. But the x is out the front, so I don't need that in the bracket anymore. Now for the third and the fourth term. Now, I know I need my brackets to be the same. There's a minus sign here, but in this one the minus sign is first. Okay? If I know I'm going to take out a factor of 4 here, but I actually need it to be a minus 4, so that our minus is now going to come into this one here. Okay, you need to make sure you get signs matching as well. So even though there's not a minus in both of them, minus 4 is the factor I'm going to take out, so that I get a positive 4y and a negative 3 here. It makes the signs the same, so that my brackets are the same. Okay? Then 4y minus 3 is my common factor out the front. And 3x minus 4, I collect that into the second bracket. One more. You're nearly there. One more. So let's see. If you look at these ones, the temptation is probably do the first one and the third one together. Has anyone gone ahead and done this one? Yes. Did you do the first and the third? Yeah. No? Yes?
I tried it.
You tried it and didn't work? No. All right. Instead, try doing these two together. But what do you notice about those two? If you just looked at those, that's actually just a difference of 2 squares. So if we take those two terms, we would get s minus t and s plus t. Difference of 2 squares. Just taking those first two terms. In the third and the fourth term, there's no common factor there, but I'm going to put it in brackets just so that you can see there's an s minus t in bracket here and an s minus t in bracket there. So there is my common factor for my next line. S minus t is my common factor. The leftover parts is this bracket, the s plus t. But what about the second bracket? What do I get from here? Plus 1. And that's how you factorize it. So that one was a bit of a tricky one. That's it.